Think back to lesson 8.4 when we were talking about multiplying special cases. Those were where we had the square of a binomial and then we had the product of a sum and difference. And I told you then that with multiplication, you could always use FOIL method and get the same answer, but you need to understand those special cases because you've got to use those whenever factoring. Now, as far as factoring perfect square trinomials, I will tell you up front that you can factor this exactly the same way we have factored the others, where you multiply the A and the C and so forth. Just like this one, you could factor using the simple method of finding the product or the factors of 16 that add to equal 8. You're going to get the same answer. However, this is much faster and it's going to save you a lot of time whenever you can identify these perfect square trinomials. So if you remember, this is what we started with when we were multiplying, and you always write it out. There could be two of them, but this was like the shortcut. This was the form that we were filling out. We squared the A, we squared the B, that was the first and the last, and then the middle term we got by multiplying the two terms together and doubling it. And the only difference in this one and this one was the fact that one's addition, one's subtraction, so it changes the sign of that middle term. But what we're doing here when factoring perfect square trinomials is we're looking to see, are they perfect squares? Is x squared a perfect square? Well, of course it is. It's x squared. It is a perfect square. And then is 16 a perfect square? Well, it is. The way you can identify perfect squares is knowing them quickly. Think about what would you square to get 16? Well, that would be 4. Think about square roots, perfect square roots. That would be your 9, your 16, your 25, your 36, because when you take the square root of those, you get a whole number. So what we're going to be looking for in these examples are having perfect squares in A and having perfect squares with the C term. Then we have to make sure that what we have in the middle fits the 2AB. Basically, if I multiply x and 4 together and then double it, do I get 8? Well, x times 4 is 4x, and doubling that is 8x. So this is the case for this one. The same goes for the one that's a little more complicated here when a is 4 instead of 1. But again, just a shortcut in factoring perfect square trinomials. So let's look at some examples here.
In this problem, you will factor a perfect square trinomial. What is the factored form of x squared minus 12 times x plus 36? Will the answer have the form a plus b squared or a minus b squared?
Now, the reason why they want you to think of this is because that's going to help you to identify which form you need to use whenever factoring. But all you need to identify is, are we dealing with a plus or a minus with our middle term? Okay, we're subtracting 12x, so think about which one of these it's going to identify with.
The middle term, negative 12 times x, has a negative coefficient, so the factored expression will have the form a minus b squared. Start with the original expression. Write the last term as a square.
So basically the square root of 36 is 6. What number squared gives you 36? So that's why they broke that to 6 squared.
A perfect square trinomial can have the form a squared minus 2 times a times b plus b squared. Find a and b in your trinomial to determine if it is a perfect square trinomial. Does the middle term equal negative 2 times a times b?
All right, so you've got to be able to identify, looking at this form and looking at what you have, what's going to identify as A and what's going to identify as B. Now, this is why it's really important to take the C value, the 36, and write it as a perfect square, because a lot of people want to use 36 as B, but notice this isn't just a B, this is B squared. So you've got to rewrite 36 as 6 squared. That way you have your B squared. So our A is X and our B is 6. Then ask yourself, does the middle term fit the negative 2ab when you plug in your x and your 6?
Yes. Negative 12 times x equals negative 2 times x times 6. So write the middle term as negative 2 times a times b.
Remember, a was your x, b was your 6.
Now write the expression as the square of a binomial. Remember, the middle term has a negative coefficient, so the factored expression will have the form a minus b squared.
So notice they're just plugging x in for a and
So
6
the
in for
expression
b.
in factored form is the quantity x minus 6 squared.
This part right here may not be necessary for some of you all, but this is a very good way to identify and make sure that you have a perfect square trinomial. Occasionally, the first one and the last one will work, but the middle one will not. So always be very careful with that.
Now it's your turn.
All right, so take this trinomial. This one has an addition sign, so think about what the form will look like. Take this trinomial and factor it. Now, think about what should the first term and the last term look like so you can identify your A and your B. Double check and make sure the middle term fits the 2 times A times B. And then just fill in the A and the B in the square of a binomial expression. Pause the video if you need a little more time, but I'm going to show you the correct answer for this. You should have x plus 3 quantity squared. And the solution for that is just simply to rewrite this in the form a squared plus 2ab plus b squared. That's what they did. And that way you can identify what your a and b are and rewrite your expression. Now, for this problem, we've got, just quickly going to go through this one, but we want to factor this one. And the difference in this one is that we have a coefficient of 4 in front of our x squared. So for this one, we're looking at the pixels, and we want to know what the area or what the dimensions of the pixels will be if this is the area of 1 pixel. So I'm just going to bring up the solution here just real quickly so you can look through there. Basically, though, what you need to take into account here that you didn't have to in the last problem is that 4x squared, both of these have to be written as a perfect square, as a square of something squared. So 4 has to be broken into the 2, and x remains the x. That way, you have to think this is your product to a power rule. 2 squared would be 4, x squared would be x squared. So your a value for this problem is actually just 2x, not the x, but both the 2 and the x together. So that's why 2x is represented here for the a, and 5 represents our b. Now notice also when you rewrite this, ab, 2ab, a is 2x, and b is 5. So I want you to look through there. I just wanted you to see this expression. It is important because we are looking for dimensions of this pixel, but I wanted you to basically see how they simplify this whenever you have a coefficient other than 1 in front of the x squared. All right. Now, before we start difference of two squares, I want to show you what this is going to look like. This is going back to the product of a sum and a difference. Remember, product of a sum and difference, we had two binomials that were identical, except one was a plus and one was a minus. And you could use FOIL method, or you could use the shortcut where you square the a and square the b, and it was always subtraction because a positive times a negative will always give you a negative answer. So this one, you have to know this one when factoring because you're going to have a binomial that they're going to ask you to factor, and a lot of times that's difficult if you don't have a GCF. So if you don't know your difference of two squares factoring method, you may not be able to factor this one. So let's look at this example real quick. We have z squared minus 9. So we want to know, does it fit in that difference of squares rule? Okay, so if I bring this over to the side here, does z squared, does that represent my a squared? And can I rewrite 9 so that it represents my b squared, a number squared giving me 9? If you can write it like this, then you can factor it out into the two binomials. All right, so we've got, let's look at this. We've got z squared minus 9 equals z squared minus 3 squared. So we can rewrite that 9. Z is our A, so we write it where A belongs, and 3 represents our B, so we write it where the B belongs. And then you notice one's plus and one's minus because that's the rule for the difference of two squares. Okay? Now, they used FOIL method here, or you can use the shortcut that you know with the product of a sum and difference. And you do get z squared minus 9, so you can always make sure that you factored that correctly. All right, so I want you to try one real quick. V squared minus 100. Can you rewrite that so that it's a squared minus b squared? Pause the video if you need a little more time. These may not take as long as the others, but your correct answer is v plus 10 and v minus 10. Okay, so simply all you're going to do is just rewrite it as v squared minus 10 squared. V represents your A, 10 represents your B, and you have a product of a sum and difference.
In this problem, you will factor a polynomial that is the difference of two squares. What is the factored form of 16 times x squared minus 81?
Now, this one, pay close attention. It's similar to the perfect squares that we were just looking at, where the a squared, or the a, the number in front of your x squared, is something other than 1. So pay close attention to how they actually factor this. It's going to be similar for you with the perfect square trinomials.
Start with the original expression. When is a term of the form a times x squared a perfect square? A times x squared is a perfect square when a is a perfect square. For example, 16 times x squared is a perfect square, but 17 times x squared is not.
Basically what it's saying is that the a, or the coefficient of x squared, because x squared is a perfect square, but the a has to be a perfect square. So if there's a 1 there, that one's simple. 1 squared is still 1. It's obviously a perfect square. But any other number that you're going to have in front of x squared has to be a perfect square, like 9, 16, 25, 36, so forth. Any other number other than those that will continue on will not be a perfect square, and therefore you can't use difference of two squares.
Now write each term as a square. So write 16 times x squared as the quantity 4 times x squared. And write 81 as 9 squared.
Notice that is the product, a product raised to a power, okay? 4 squared would be 16, x squared would be x squared. So you write 4x in the parenthesis because it has to be, all of that has to be squared in order to get 16x squared. And then 81, that one's pretty simple. It's just 9 squared. So now you have it in the form a squared minus b squared, where all of this right here represents the a.
Use the difference of squares rule to write a squared minus b squared as the quantity a plus b times the quantity a minus b.
Like I said, the 4x represents your a and the 9 is your b.
A is 4 times x and b is 9. So the factored form is the quantity 4 times x plus 9 times the quantity 4 times x minus 9. Now it's your turn.
All right, so this one is similar to the last one. Make sure d squared is obviously a perfect square, not a big deal. Make sure 25 is a perfect square. Is there a number squared that would give you 25? So rewrite this as a squared minus b squared if possible, and then use the a plus b times the a minus b to rewrite it in factored form. Okay, I'm going to go ahead and show you the correct answer, and I'll show you the solution page because we are running out of time here, but it is similar to the last problem.